Hello, Internet, and thank you very much for tuning into the CloudNative.fm podcast. And I'm your host for the CloudNative.fm podcast. And this show is bring you to all the open source and cloud native things in this show. And today we are talking about a very critical subject. And let me introduce the agenda for the topic of today. So a typical organization can expect to have 10 or hundreds of Kubernetes cluster spanning multiple operating environments or business units. A key customer challenge is to ensure that they can provide their developers and operational admins seamless access to the fleet of Kubernetes cluster based on their role in the corporate directory. And in this talk, we'll look at the CNCF open source ecosystem and one of the tools that has recently been open source called Paralus, how this tool can help us achieve seamless access to the remote access to Kubernetes cluster. And let me introduce my guest to you today, Mohan Atreya. Thank you very much for joining on the show, Mohan.
Hello, Saim. Good to meet you. Thank you for the opportunity again.
Yeah, so can you tell us our audience about your background, where you work from, and all the details about your
Oh,
career?
sure. Absolutely. I mean, I actually have some of that in my slides, so let me kind of bring that up if that's okay, and we'll just run through that so they can see it and hear me talk about the same thing. Okay. So a
Yes.
little bit about me. I've been at RAFE, the key contributor and sponsor for the project Paralus for about 4 years now. And prior to RAFE, I was at a company called Okta and a bunch of companies in the San Francisco Bay Area where I live. Um, that's my background, Sign.
Yes, thank you very much for the introduction as well. And let me tell us about your journey, like being how what is the challenges in the Kubernetes space. We look at it. There is so many parts. We have so many layers in Kubernetes. To be honest, like we have infrastructure layer, the cluster, and
Mm.
people like to call it the 4C in the cloud: the
Yeah, yeah.
code, container, cluster, and cloud. So, what do you think is most challenging aspect of zero trust in terms of Kubernetes clusters?
Yeah, yeah. This is yeah. We had a very interesting journey with this particular project, uh, and I'll maybe kind of rewind in time and kind of talk through. There's so many challenges in the Kubernetes space, and maybe I'll take a help the users kind of understand how we arrived at Project Paralus, what gave birth to it. It's actually been a very interesting journey over the last 4 years. So about 3 years ago, um, we when we started working with a lot of organizations, Kubernetes was still early for them. They had one or two clusters, um, and as they started expanding to many business units inside, many developers inside, and when they had issues, they were struggling with RBAC. They were struggling with and the experience for users, as in developers hated getting on a VPN, a Bastion. It was just a frustrating experience because what they were doing was no longer just one or two ops people that needed access. That was true for the previous generation of systems, like think virtual machines, etc., where just the ops person or the SRE needs to access the cluster. Here, what we found was more and more people, developers and other people, also needed access because microservices no longer a monolith, right? That one application now has become like 20 microservices, and only that developer would know anything about their microservice, so they needed access. So organizations were starting to struggle, and a lot of us at RAFE come from an access and a software defined perimeter background. So we kind of understood the space and we said, hey, could we do something about it? And that gave birth to a piece of technology that we implemented in our platform at that time. What we did not foresee at that time, about 2.5 years ago, was all of us started struggling with COVID. All of us started working at home. Developers were at home. No one is coming into office, and that zero trust access took off. It became the most used part of the platform. So what we decided at the time was, man, this is so hard. This is so interesting for people. Why not open source it and contribute it back to the community? Um, so that's what gave birth to Project Paralus, and we took our battle tested, enterprise hardened piece of technology, and we said, hey, we got to give this back to the community so that everybody can use it. People should just stop using legacy technologies to solve this problem and do things a different way on Kubernetes. So that gave birth to Paralus. It's completely open source. We'll talk more about it. I don't want to steal Saim's thunder here. And we'll talk more about the use cases. I'll kind of do a gentle introduction today along with Saim. And you can see some of this in action, and you'll also see some concepts in slides. Was that a reasonable background, Saim?
Yes, absolutely, absolutely. You can go through the slides and I will ask question as we go.
Sure, absolutely. Yeah. So, why is access so important? And I think Saim's been kind of talking about this in the early part of the session here about, why is this so important? Once a cluster is up, that's the easy part, getting a cluster up, right? What you do with it after that is the most important thing, right? And what we see in the market is a very dangerous situation. Because accessing a cluster through a bastion or something else is so frustrating for users, a lot of people tend to take the easy route. The easy route is put it on the internet, right? And now we're not making this up. This is a report that Shadow Server published some time back, and they keep publishing it with updates. There's a lot of clusters on the internet, open on the internet. And a Kubernetes cluster, if you have its API server reachable on the internet, in some ways is game over, right? Like they can interrogate it, they can talk about it, they can learn so much about it. Why would you ever do that, right? So that is a very important thing, and we think people do this not because they're lazy, but because they don't want to deal with the downside of brokering access to Kubernetes through legacy technologies. So with that, let's look at what are the technologies that previously have been used for access to not just Kubernetes, but maybe a data center or a VPC or in the cloud, etc. Right? Let's look at that, and we'll kind of learn why these are so clunky and why they are hated by developers and users. The first approach is a bastion, right? This is like, everybody here has probably heard about a bastion. And what the bastion does is, imagine you have a private network. You're going to open that up to SSH tunnel, and then the developer has to SSH in, or developer ops SSH into the bastion. And from the bastion, there'll be a bunch of utilities installed there. They can run kubectl or whatever, right? Everybody here knows this, right? What are the downsides with that? The number one problem is, if you have many data centers, many regions on AWS that you're accessing, now you need a bastion per data center. That gets problematic. The bigger problem, I would say, is all the users coming in. If there are 10 users SSHing in, all of them are going to use pretty much the same kubeconfig for the kubectl utility. And not only that, from the bastion, you have access to everything inside that private network, not just that Kubernetes cluster. You can touch and feel everything. This is a fantastic opportunity if you're an attacker, right? You would want to do something about it, right? As an attacker. The second problem is that of a jump host, right? So people say the bastion is not working for me, so they would do the next logical thing, which is a jump host. And what they do is they put in a jump host in front of the bastion. And the problem with this is it doesn't really solve a problem. You essentially are opening up, you're putting a double layer process, and then the user has to now deal with jumping into the jump host and then going into the bastion, which is very frustrating from a user experience perspective. Sometimes the security teams ask you to do that. A third approach is that of a VPN. In a VPN, you install a gateway, and the advantage with a VPN is you can shift you can increase and improve a user experience by shifting some of that to the end user. So if you look at this here, it is a little better because instead of using the same kube config at the bastion for all users and being unable to differentiate between user A and B, here you can give them unique kube configs. So the VPN client, they just turn it on, they connect to the VPN concentrator, and the developer can run kubectl right on the laptop. No need to get on a bastion, which is going to be painfully slow and all that, right? But VPNs cost a boatload of money. They are not cheap. They're extremely expensive to operate. So people say, man, this is a problem. So the question that everyone's been asking in the market is that a different approach, a better approach? Because all these approaches, as you can see, right, they're not exactly secure. But they're better than opening up on the internet, but there's a big security problem here. And that is what led to the entire project Paralus, which we'll demonstrate in a couple of minutes once we go through the second problem that needs to be addressed. Are there any questions, Saim, or should I continue?
Yes, absolutely, absolutely. I think everything that you is to just. I think everybody is struggling to see that because we have so many clusters that is widely available, and we made those clusters available for the wider audience because they want to install some of the software on it. And Kubernetes is all about ecosystem. You just not configure Kubernetes is not done, but you installing more and more apps on top of it and giving access to the clusters, the users, and the teams, and everybody accessing to it. And that is eventually the come of the model. Like you want to give them a least privilege access in order to avoid the cluster misconfiguration or security holes that did not tap into it. And now, absolutely, and now you can discuss Paralus, and I will ask question. I'll continue monitoring the chat, and we'll see how people can join and ask question.
Okay, sounds good. Okay, so now we talked about, in the first section, we talked about how can I access these clusters. Once I have these clusters, I'm able to reach them. The next question is, hey, what privileges am I going to be given on that cluster? Now, the worst thing anyone can do is give every developer, a highly privileged access to the cluster because they can do a lot of damage without realizing it. So in Kubernetes, there's a concept called an RBAC. Now, this is very important to understand because I'll be talking about this when we talk about Paralus. So let's maybe do a quick baseline on this. That's at a high level, there's two simple ways to look at it. A cluster administrator, typically an operations person or an SRE or something like that, they need cluster-wide access because they need to do things across namespaces on the cluster, and they're typically assigned what is called as a cluster role binding, which maps to a cluster role, which gives them access to cluster level resources. So that's typically an ops and SRE person. It's not right to give that to a developer. They don't need it, right? Because they're typically dealing with their namespace, right? Namespace is a multi-tenancy concept in Kubernetes. And as a result, it's ideal to shrink access for a developer and say that, hey, I'll give you a role binding, which maps to a role mapping to a particular namespace. And you can do things inside that namespace, like you're an administrator of the namespace, like, deploy a pod, modify a stateful set, all those things you can do, but you can't do administrative things. So this is a typical two-level separation that has to be implemented in Kubernetes when you have many, many users. All looks pretty straightforward, right? Like not that hard to understand. But let's look at what happens at scale, right? Because no one's going to have, just this 2-3 clusters, right? People are going to have plenty. What people really have is tens or hundreds of Kubernetes clusters, maybe sometimes deployed across the world. And as your thing grows, as many, many applications are deployed, you typically have hundreds of developers and operations people, and not everyone needs everything. Um, how are you going to create these users, the RBAC, and users are going to move from one role to another, team to another? It's a nightmare to manage this RBAC manually, right? So essentially, in a nutshell, at that time, anything you do manually starts falling apart, right? You need some kind of an automation to keep this going. This is kind of the primary problem we attempt to solve with Paralus, because what it allows you to do is federation of this RBAC, right, with automation. So what do you need for zero trust access? Let's look at that, right? Um, it's a really bad idea to have your Kubernetes clusters open on the internet. Your Kubernetes clusters need to be cloaked. They should not be visible directly on the internet. But as a developer or an ops person, you should not be put through, asked to jump through hoops to access these remote cloaked clusters. You should have seamless access to them, right? Um, Credentials should never be permanent. If I have access to cluster ABC today, doesn't mean I need access to that tomorrow, right? There has to be an evaluation all the time to say, hey, does Mohan still need access to that cluster? So any credentials should be ephemeral, and they should be injected just in time in an automatic manner with least privileges. A really important aspect. So we'll see that in action. And all access needs to be authenticated, right? Like, you want to make sure all forms of strong authentication is used here for users. And perhaps the last part, which is kind of understated in many cases, people don't realize this until they have a serious problem. And we see this as a really important aspect of zero trust. Just because Mohan can access a cluster and do stuff does not mean that my requirements are complete. At the end of the day, the security team or the governance team in a company will come back and say, hey, can you prove to me and show me what Mohan did on these clusters at time, on this day and this time? They need a way by which they can have an audit trail of all activity performed by these users, especially over kubectl, to make sure that there's no malicious attacks or no accidental issues, etc. So we'll see that also in action. Okay. So with that, maybe we'll talk about an amazing open source offering that attempts to solve all of these problems, which is Project Paralus. Where can you get it? So it's an open source license, an Apache license, and it's available on GitHub. Just go to paralus.io and download it and use it. It's extremely easy to use, and we have made a bunch of effort to make sure that we have get started guides for EKS, AKS, DigitalOcean, and a bunch of other environments. You can even use this on your laptop, like a micro-KRS environment. If you have questions and you need help, you can always interact with us on Twitter, or we have a Slack channel as well. So do try this out and work with us. We're happy to help you. I'm not going to go through every feature here. We'll kind of cover that in a future session. But for now, I think we're going to look at a couple of things, like how does this work? I'm sure you're curious about. You heard about the Bastion. You heard about all these things. Before we see a demo, let's kind of see how this works. Why is it so different, and all of that, right? So there are two components of Paralus. There's a Paralus access server, a proxy that you will set up. You'll install it somewhere in your network, right? And in every cluster you have, let's assume here you have 2 data centers. You will deploy a small Paralus operator, Kubernetes operator, right? What that operator does is, think of it as having 2 hands. On one hand, it'll dial out to the Paralus server and establish a long-running connection, a gRPC connection. And the Paralus operator also has the ability to talk to the API server on that Kubernetes cluster, right? And in this particular case, it's steady state. I have two clusters with the Paralus operator running on that, establishing a dial out connection. In most data centers, a dial out on port 443 is typically allowed. That's the only way you can access internet, right? So key point here, there is no need for the server to connect in. It's always a connect out. So these things are dialing out to talk to the Paralus access server. Now, what happens next here is imagine if I'm a developer or an ops person. I just have a laptop, right? I can either use, I can log into Paralus, and I can use a browser-based kubectl shell for convenience. Or if I'm a pretty savvy, CLI user, I can use the kubectl CLI, and I connect over port 443 to the Paralus server. And I say I want to access one of these clusters. The Paralus access server is going to say, hey, who are you? Can I authenticate you? And this authentication can happen either with a local user, or you can connect it to your directory. If you use Okta or Azure AD or GitHub, there's so many identity providers that exist. So you can connect Paralus to your source of truth for identity, and Paralus can offload the authentication to that identity provider for single sign-on, or it can have local users. Once it does that, it says, okay, I know who you are, Mohan. Then it'll say, well, what RBAC should I give you, right? And because the user can move across, they can change roles and all of that. Now it's going to say, okay, I'm going to determine RBAC, and that'll be based on certain roles you define in Paralus. And you'll basically say, Mohan can access this cluster or this cluster and this namespace or this namespace. That's a dynamic decision that's made at that point in time. Once that is done, a very important thing happens. The Paralus server interacts with the operator here and says, hey, here's a service account for this user, which is valid exactly at this point of time. Can you please provision that service account on that API server and do this right now? And it's got a certain lifetime. It's not a permanent account. It has got a lifetime associated with it. So it's an ephemeral service account that gets provisioned just in time on that API server. Once that is done, the Paralus server simply acts as a transparent proxy. You type a kubectl command, it'll send it to the API server, it'll receive the responses back, and it basically says after that, hey, I'm not in the data path. I don't need to interrupt anything. Just keep sending things back and forth, do your job. Once the user session is complete, and let's say you're logged out, the Paralus server will go tell the downstream operator, hey, please go remove that service account, right? Its lifetime is over, please remove it. What this means is there's no permanent credentials on these clusters, right? So it's very secure. And tomorrow, let's say my role changes in the company and I don't have access to this cluster anymore. My service account has been removed already. And when I attempt to access, I'll be blocked, right? So all this just happens automatically and seamlessly. You don't have to deal with anything, right? So a typical user of Paralus, they land up saving hours of time and headache with this whole process. Now, the final thing here, all this happened. I typed a bunch of Kube API. I sent a bunch of kubectl commands, right, to the cluster. All those, since they pass through the Paralus server, they are audited in a database, right? There's an audit trail of everything. So they'll know, the auditor can go and check, oh, you typed this kubectl command, then you type this kubectl command. So you can reconstruct who did what and when, right? Really important from a compliance perspective. Yeah, so that's how it works. So if you use this Paralus, both security and governance, right? Really important aspects for companies. Access and secure access and zero trust based secure access is the modern way of protecting and securing access and delivering a great experience for your users. So our recommendation is do try this out. It'll be really important for you organizationally. You'll be a hero inside a company because your developers will love you for enabling them to do their jobs faster and better. Okay, so let's see this in action. You've seen a lot of slides.
Yes, and Mohan,
Yeah,
can we just address some of the few questions here in the
sure.
chat?
Yeah, let's go for it. Let's go for it.
So, Social Maharaj is asking, would want to know, understand more about least privilege access.
Yeah. So let's go back to that. I think I had a slide here. I can talk to it, and I will see a demo of that also, right? So least privilege access is a very critical security pattern that is well accepted and desired. Kind of hard to implement without automation, but it's really important. Um, so why does this matter? Maybe an analogy here will help, right? Um, at a typical organization, an app developer only needs access to a particular namespace, one or two namespaces, right? Um, they can do things inside that namespace, but they don't need to see anything outside that, right? Um, Now, that's an example of how you want to make sure that the developer is locked in into what their job needs and not anything more, right? So that's a very important example of how least privilege model helps you shrink your attack surface. Because if you say that, hey, developer, I trust you, I will let you I'll let you have complete access to the cluster. Well, that's a big business risk, right? Because what if the developer is malicious? What if the developer's credentials get compromised? And let's say they do get compromised. Now, the developer here, all they can do is stuff inside that namespace. They cannot do anything on that cluster. So at least the damage that is done is isolated into that little area. So the blast radius, like something goes wrong, the blast radius is very limited, right? So this is what people like to do, right? The least privilege model helps you reduce the blast radius and contain the blast radius, because in the security model, you want to shrink the blast radius. Everything you do is an attempt to shrink the blast radius, right? Without messing up user experience, of course. So
Yes,
hopefully I
absolutely,
answered
absolutely.
that, Simon. Yeah.
Yes, absolutely. And I think people like to think about the cloud as well. Like in the cloud, you have a least privilege model. And how do we control and how do you make sure that you have a least privilege model? Is using the IAM policies like identity and access management. And in Kubernetes, we don't have the user, but we have the roles and role binding. And that's complex for a lot of the people. And that's the good thing about Paralus. It's making sure that's already been set up. Don't mess up the cluster. Now we give you the role, and on that role you can do these certain things, but not do certain beyond that. And another question from the Mars Hogo: what about SSH certificate based authentication? Isn't that provide identification for each user?
Yeah. All these is a great question. Um, and with this, maybe the fundamental question to think about is, see, SSH made sense, um, in the previous generation when all you had were virtual machines. Um, with SSH, you kind of have access to a lot of things, right? Because once you SSH in, first of all, you need inbound access to SSH. And there are some technologies which flip that around, that's for sure. But in general, with SSH, when you have access to a lot of things, and again, you have a surface area problem, right? If I as a developer need access to a pod, why are you giving me access at the OS level? Why do I need it? Right? So ignore the authentication for a second, right? I'm even questioning the fundamental rationale behind SSH here, right? Why do I If a person needs access to a room, why are you giving him access to the palace? Doesn't seem to make sense, right? And that's the problem with SSH. Um, uh, I'm not saying SSH doesn't work. Sure, you can do it, but the user will have access at the lowest possible level, which means they have way too much access, which kind of goes against this least privilege model, right? Why do they need access to anything beyond what they need? So with some the reason for Paralus here is, can I shrink that down to just the namespace, right? They will not see anything else. They don't need to know there's a worker node behind it. They don't need to know there are other VMs in that data center. They don't need access to the virtual machine underneath. Why do they need it as a developer, right? So that's kind of the reason why you have to find a way to shrink access down to only the protocol they care about, only the thing they need access to. And then that's kind of what we're trying to say here, right? So I'm not saying SSH is bad. It's just that it's a very wide surface area. The blast radius is enormous if you use SSH.
Yes, absolutely, absolutely. I think the people like to think about it that we are living in the GitOps world, and Kubernetes has Argo CD and Flux controller running, and they acquire a namespace where then can they sync the state into the GitHub repository and do certain things. And if you give somebody access to the cluster, what happens if they delete a namespace that the Argo CD is managing? The entire cluster, the production system is going down. So I think for the RBAC and the SSH doesn't help you with that. And for that reason, you need RBAC or some kind of tool that give you not gain much, but what you need is already been there for you. So I think you can think about on that way as well.
Yeah,
So go ahead,
absolutely.
Mohan. I don't see the question, and we love to see the demos going.
Okay. So I'm going to show three demos here, right? So I think we have some time here, so we'll kind of cover all three slowly, so people can kind of experience it. The first scenario you're going to see is me as an operations person uh, using Paralus to access two remote clusters using kubectl in a browser shell, right? Really, really simple experience. I want to show that, right? The second thing I'm going to show is I'll kind of walk through how just-in-time and ephemeral service accounts with automated federation of RBAC is performed um, for, let's say, a developer, not an operations person, but maybe for a developer who just needs access to one cluster or something like that. We'll see how those are created, right? And the third thing we'll see is, these two users, the operations person for scenario 1 and the developer for scenario 2, when they would have performed a bunch of kubectl commands, right, on that cluster. How do these look like in the audit trail? We'll kind of see all these three, right? There's a lot more to show here, like integration with for single sign-on, etc. But I think from an attendee perspective, it might be very hard to absorb all of that in one shot. So we'll kind of start with some three simple scenarios and go from there. Okay. So what you're going to see here is this. The scenario I've modeled out is I'll have a production cluster and a staging cluster. Very common. Almost every organization will have something like this, right? You'll have a production cluster and you'll have a staging cluster. Then we'll look at two personas. We'll look at the ops and SRE persona. Of course, they need access to both, right? They're the ones helping with the health of the cluster, status of the cluster, and all of the stability of the cluster. So in this example, the ops and SRE person, they will have access to both production and staging clusters. But for the developer, actually, this should be flipped the other way around. Sorry. The developer will have access to the staging cluster, but not to the production cluster, right? So sorry, this is flipped around. So we want to make sure that this is automated. The developer, when they log in, will see their roles, and we'll see how automatically they only have access to the staging cluster and not the production cluster. So let's see that in action. And Simon, I hope my screen here is visible, right?
Yes, I can
Yeah.
see it. I can see it.
Okay, perfect. So first, what I'm going to do is, before I go on to the specific scenarios, let's log in and see what Paralus looks like. In this particular case, we set up Paralus. This is running in a data center in New York. And I'm going to log in as an administrator just to kind of give you a look at what this looks like, right? Now, what I've done here in Paralus is I've mapped these two environments, production and staging, into a concept called a project. A project is a logical isolation boundary, right? Which means I can set rules around it. I can set access permissions around it. And it's a way for me to contain the blast radius. So here I have a project called production. And what I've done here is I've gone and said, I'm going to look at membership in this. So I basically said, anyone who belongs to the group called production will have access to this with this role, right? Of course, I can go change that. I can go change that and say, hey, there are various other roles that are possible, but for now, let's just assume, keep it simple, right? So any user that belongs to the production group will have automatic cluster admin role access in this project, right? And who are the assigned users? I haven't assigned users, but I've assigned groups. So if you go look at the users here, I have two users. I have this user called SRE@rafe.co. If I go look at the guy here, this user belongs to two groups. There's a production group and a staging group. So this user automatically will inherit the roles associated with the production group and staging group. So we talked about this ops person. He needs access to both. So instead of me managing users one by one, which is very frustrating, right? What I would do is I would create a group, assign it a certain role, and I can just remove users from groups. In this particular case, this guy, SRE@rafe.co, belongs to these two groups. A very simple model, right? The second group I have is called staging. And in staging here, you notice here I have two users that I've added, the developer at rafe.co and this, right? And I also have this group is assigned to the staging project. So just like here, the staging project has the developer has access to it. Very, very simple, right? So now I'm logged in right now as a top level admin, right? I'm a root level admin right now, and I'm showing you everything, right? So there are two projects here, and let's go look inside this production thing. So here I have one cluster called production, right? And if you go look at the other project, staging, I have a staging cluster here, right? Now these two clusters are running in very different places, right? So this cluster is in one data center, and in the production cluster is in a very different data center, right? Now the one question that people may have is, hey, how did this cluster get in here, right? So it's a very simple process. All you have to do is, assume you take care of cluster lifecycle management yourself, whether you provision an EKS cluster, AKS cluster, whatever, right? You can just import that in either using the UI, or you have an option of using the CLI, or you also have APIs for this. So, how you want to automate this, you can integrate this into your CI/CD pipeline. And every time you spin up a cluster and you want Paralus to become the access manager for that, you use a CLI or API, or you can do this using the UI and simply import that in, and that brings it in. Now let's see what gets deployed on this cluster. All right, because I talked about, remember, from an architecture perspective, I said there's a small operator that gets deployed, right? So you're presented with a kubectl web shell, and you can interact with that web shell. And if you notice here, there's a namespace called Paralus system. And there's a resource that gets deployed inside this Paralus system that is what is connecting back to my Paralus access server. Okay. You can also download a kubeconfig and use kubectl CLI to do what I just did using the shell. The advantage of the shell is you get autocomplete. Who remembers all these commands, right? You get autocomplete and you can do your job. Now, let's go back to that scenario. Now we're seeing this general baseline of how you can access these clusters. This cluster is behind a firewall, but I'm able to touch it using kubectl. So now let's go into the second one, which is as a developer, now let me access this. Now, remember what we said. As a developer, I will not have access to both projects. I will only have access to the staging project, right? So let's see that. I'm going to now log in as a developer here, and I'm going to the same console. And when I log in, because I am a developer, I only have access to the staging project. In this case, I given cluster privileges, and I go here. I can still access the cluster here. And what I want to show you now is the just-in-time service account, right? So if you go into that Paralus system and you list the service accounts, you'll notice that a service account for this developer at rapid.co was injected 8 seconds ago. Remember I talked about there's no permanent credentials? So this guy here was authenticated, authorized, and the service account was injected here just in time. And if you could describe the service account, you can see what the structure is like, and you'll see it has a lifetime associated with it. It'll be automatically removed at a certain time. Okay, so I'm going to do a few more commands here just to kind of trigger a bunch of commands from an audit perspective, right? So I've done a bunch of commands here, and I can also do this using the CLI. Now, let's go back as an admin and look at part 3. The part 3 here is I did something on the cluster. The developer logged in but did a bunch of kubectl commands on the cluster. And maybe 1 month later, the security team says, hey, can you show me who did what and when on these clusters, right? So there's an audit trail that's maintained. So you go here and you look at the audit logs. And if you flip to the kubectl tab, and if you notice here, and you can do it by user. So there's 2 users who logged in. So as an admin, when I did the first scenario, I typed this command called get namespace. You just saw me do that, right? Now, what did the developer do? The developer typed these 2 commands. I just, you recognize these 2 commands that I just typed a few minutes ago. All of this is tracked and audited. And this data can be exported out to a Splunk or something else, or you can use APIs to suck it out and integrate this with your long-term forensics and analytics system. And that covers the audit trail. So in summary, what you just saw here is this. As a user, I was able to remotely touch these Kubernetes clusters. Even though they were behind a firewall, I was able to access them right from a browser, right from a kubectl CLI sitting on my laptop, right? I didn't have to go through a bastion, and I had a very contained blast radius, right? I could only do kubectl commands. I could not see anything else. I don't need to see anything else in the VPC, right? Very shrunk down blast radius. My access was ephemeral. Based on my current authentication and authorization and role in the company, I was given access to what I need to see only for a certain time period, right? And all access, I had to authenticate in to see it. And then finally, I had a complete audit trail. As a company, I had a complete audit trail of who did what and when across all of these, right? Another thing that may be implicit here, which I kind of didn't spend time on, I'll just show that very quickly from an authentication perspective. So if you look at this kubeconfig that is used to authenticate, it's all based on mutual TLS. So when you download this kubeconfig, what's happening here is the end user is given a kubeconfig using a two-way authentication based on certificate authentication. So I need to have the right certificate, which has a lifetime, and I have to demonstrate I can authenticate with the Paralus server, and the Paralus server will authenticate itself. So the two-way authentication. So there's no man in the middle possible here, right? So that's the other aspect of zero trust. So with that, Simon, I think I would encourage everyone to go to paralus.io. Just go to paralus.io. You have documentation on how to get started step by step. Our team blogs significantly. You can go look at the code if you want. It's completely open source, so you can go look at that and join the Slack channel. And we look forward to working with you on as you try things out. We'd love to get your feedback, and please contribute if possible.
Yes, absolutely, absolutely. And that's demos look as wonderfully well because if you look at the Kubernetes, there is a RBAC that is quite a complex and heavy topic to learn because in Kubernetes we don't have users and there's no user concept in Kubernetes. So you have to set it up like what role sign has in, let's say, in the production cluster. So previously, without having this tool, I have to set it up RBAC, and this is quite a complex for the some of the companies, some of the people, because you have to assign a role. That role has some role bindings, and that is a quite a heavy tree to understand how deep things are working there. But if you look at the Parallels demo, if you log into there, you can select from the dashboard that SIME has a don't give access to the production system, and it's already a part of the group. And that group don't have the permission, and you just need to add me on that group where you don't have access to the production system. So it's a just one click of a button. So that's a wonderful thing that I learned about today. And another thing, I think the other open source tool, I think the lack about this prospect in Kubernetes that it don't give you the audit trail. And if you look at the Paralus dashboard, it can you see like on 8:30 p.m. Sime has accessed the Kubernetes cluster and he has created a resource called, let's say, Sime namespace, and he's deployed some production, some application on it. So that's the audit trail that you can work with it. And also, if that zero trust is actually mean that you're giving developer a tool that it can learn from today and start thinking about how the stuff work in the production system. So I think that's another way of thinking about this project as well. So I think it's very cool feature in it, and I hope in future I hope to see more people and more open source communities like to get involved into the Parallels open source. And I hope to see Mohan has more speaking in Parallels around KubeCon and other talk as well, because the demos and all the things that he showed us tonight is makes sense for a lot of the people, because this is a fight in the Kubernetes ecosystem to how give access to the secure, because there's not just people, but there are third-party services that access to the Kubernetes cluster. And we are living in the GitOps world as of today, and GitOps needs some namespaces that he can control it. But let's say if I delete the namespace, then who has the authority in it? And this is have to be figured out: is this namespace is not available from the day one, or is it deleted on day two? That's another challenge in the developer and the production ecosystem as well. And I can see another like Moz is a reply to their question. He's saying, "Sorry, I meant SSH proxy, where you authenticate by providing your identity and then get a certificate, and that certificate will have some capabilities role which defines what resources you can access."
Yeah, yeah. So it's a good point. I understand now. Yes. So that is definitely an alternative. But the question there again is about what level of protocol you need to give to the users. The question there is, why should the developer require SSH access? Do they need it? Because if I'm developing microservices, all I want to do is run a few kubectl commands, right? Why do I need SSH? I think that's a fundamental question. This goes back to the blast radius thing, which is give them only what they need. Do not give them more than that. Now, if you're an operations person, maybe you need the SSH proxy. Nothing wrong with that, because I may be doing more beyond the cluster at that point of time. Yeah. So right tool for the right person. Very good question. Very valid.
Yes, absolutely, absolutely. I think I love the product today because I see in the Kubernetes ecosystem there is a separate layer, and that separate layer need to be separately look at it. If you look at the Kubernetes ecosystem, we have seen people talking about how to sign the images by using the tool like cosign. We have some tools available in the ecosystem where you can scan the images, you can trust the images like not vulnerabilities in it. But in terms of the securing the Kubernetes cluster, in terms of accessing the Kubernetes cluster, we have very less tool available. I can know some of the tool give you some visualizer, the RBAC visualizer. You can see like what is actually the role and how it's actually developed and how it's architected. But nobody give you the full flourish control of all the things that you mentioned today, like giving the product developers only access to the staging product system, not to the production system. Also there's a tool, also the audit trail, also the revoking tool. So what is the so can you tell like what is the future plan for the Paralus?
Yeah. Yeah, very, very good question, Simon. So we are reacting and responding to feedback from users, right? So it's a very uh, community and user input driven project, right? So we are like constantly getting feedback from people, and we basically using that as a way to react and respond. In fact, if you go look at the list of issues on the Git repo, you can contribute. You can basically ask for things, and we will react and respond. Some of the obvious things that we are looking at are things like um, uh, you know uh, we didn't what we didn't realize is the kind of users who actually will enjoy this product are actually the non-technical auditors and all that, because they want a bird's eye view into who is doing what, right? So audit trail is great, but I think people are saying, hey, can you give me a dashboard where I can see this very quickly, like I think like a pie chart or some trend line and stuff like that. So people are asking for metrics, which I did not anticipate, because I thought this project would be more useful for ops personnel. So we're also learning from our users. Um, Another thing we're getting asked by people is, um, like access reviews is a very big problem in companies, right? Like, uh, especially if you're doing SOC 2 and if you have all these compliance things to worry about, auditors come and say, hey, can you show me, can you help me understand why does Mohan need access to this? Does he still need access to everything, right? Because then what it means is, yes, in Paralus, I can go set the roles, but are they the right roles for Mohan? It may be the right role for Mohan yesterday, but maybe his role changed over time. So these access reviews are a headache for companies. It's very, people deal with spreadsheets for this. What we're hearing from people is, can you make that easy for me, right? Access reviews, because there's so many users accessing this. So we're looking into some of these big things. And there's also little tuning, incremental improvements that we're looking at to make life easier, right? So again, just kind of highlighting some of the interesting things we're working on. And we'd love to have people contribute as well. We are moving at a certain velocity, but if people have ideas on how to contribute back, we love contributors. And active participants, don't be shy about asking for stuff. We'll look at everything and react and respond.
Yes, absolutely, absolutely. We hope to see community get involved with this on the CNCF side, on the open source side, and well, you can tag me on the Twitter and ask me about help on the Parallel. I will definitely encourage to help you. And we have a very less time is available, but it's a very good question by the Kai Hansen. So Parallels is not meant to also integrate with other tools, Grafana, Argo, or just a kubectl access.
Yeah. Maybe I'll take this, and I don't know if there's anyone else from the team on the stream, Saim, who might be deeper than me. Um, Usually, what I find is it's possible to integrate anything with Grafana, right? It seems to be a wonderful tool where you can suck data from anything. So I'm sure there's a way. I'm not savvy enough to know because I haven't done it myself before, but I will go look at it. I'm sure it's doable. Um, yeah, maybe that's the way to answer that question about the dashboards, right? Why reinvent the wheel? Maybe we should not have a dashboard in Paralus. Maybe that should exist in Grafana, because Grafana is so powerful in representing data and visualizing data. So we'll talk, Simon. I think we'll talk with the team, and I'm sure we can figure out a way. Very
Yes,
good question.
absolutely, absolutely, and I think the similar question is also pop up, so I can tackle this one. When you are giving access to third-party apps in a Kubernetes cluster, so it's actually saying what is actually the waypoint, because there are cluster scoped some of the things, and there are some namespace scoped. So how you give access to them? Because I think this is a question around Argo CD and Flux, so creating the namespace, and we don't want them to delete it. Like how the Parallels can help into it. So I think that's definitely the integration point. And there are some of the ways we can integrate Parallels into it. Because if the Parallels fit into this picture, and I think that's the operational. This is a best day for the operational team because now they can see what's happening in the Argo CD and plus what our operational team is doing in that region as well. So I think these two questions are that's wonderfully well, and these are the actually coming ahead. We are thinking about this integration point as well, and also who are watching this podcast as well. Please join us because we want to have some more integration and want to see how Parallels get fit into the open source ecosystem because Opens is all about collaboration and learning from each other and making sure the feature that we are driving into the Parallels are beneficial for the wider community, not just for the 1-2 people. So that's my point as well. But thank you very much, Mohan. We have only 2 minutes left. Well, that's a wonderful demo, wonderful preparation of the slides and all the content. I will just share the slide with the people as well. And thank you very much for adding these questions in the chat and hope to see in the future or on more podcasts like this. So thank you, Mohan.
Well, thank you for
We'll
a
stay in
great.
touch.
You're a fantastic host, Simon. Thank you.
Thank you, everyone, for joining us today, and have a wonderful day ahead. Bye bye. Stay safe. Stay healthy.